Plastic versus polymers. Group 15. Member of the group: Ahmad Rafi, Afrida Windy Suwondo, Fahmi Fauzi, Muhammad Husainuddin Fauzan, Sharin Louis Papuci. Plastic versus polymer. What's the difference? Although the terms are often used interchangeably, polymers and plastic are not always the same thing. Polymers can exist organically or be created synthetically and consist of chains of individual molecules or monomers. Plastics are a type of polymer composed of chain of polymers which can be partly organic or fully synthetic. Simple but all plastics are polymers, but not all polymers are plastic. Below we examine the composition, physical properties, and application of polymers and plastic to provide a clear explanation of the difference between the two. What are polymers? Polymers can occur organically in the form of natural or biopolymers, like wool, cotton, or wood, or they can be synthesized into semi-organic or fully synthetic materials. Synthetic polymers fall into three specific categories. 1. Elastomers. 2. Thermoplastics. 3. Thermoset. Elastomers. Elastomers are elastic material with high flexibility and low strength molecular bonds, or like rubber. Polymers fibers consist of polymer chains that have stronger molecular bonds than elastomers. Fibers are more rigid and less elastic than elastomers and can be composed of both natural and synthetic materials. Thermoplastics. Thermoplastics are more rigid than fiber and elastomers and are distinguished by their ability to retain their molecular structure when exposed to heat. When heated to their melting point, thermoplastic will melt rather than burn, making them ideal for shaping. The fundamental structure, physical property, and uses of synthetic polymer help to determine its classification. It is important to understand the qualities and uses of polymer to ensure that they are used in the appropriate application. Thermoset. A thermoset, also known as a thermosetting polymer, becomes set in its physical and chemical properties after an initial treatment of heat, and that makes them unaffected to the additional heat exposure.
Structure. The molecular structure of a polymer determines the fundamental properties of the material. When attempting to classify a particular polymer material, the following structure aspect must be considered. Monomer composition, knowing which monomers make up the polymer chain, how many of each, and the nature of those monomers will help to classify the material. Chain characteristic. The average length and weight of chains in a polymer help to determine the degree of polymerization and the molecular form of the polymer. Molecular bonds. The structure of a polymer can be determined by the ways in which the monomers are linked to each other and whether or not there are cross-branching bonds between polymer chains. Polymerization method. The means by which the monomers are combined into polymers determines the structure of the polymer, whether it is a naturally occurring process or synthetic polymerization through the use of heat, chemicals, or condensation. Properties. Polymer come in a wide variety of forms and can be further classified based on their physical properties. Some identifying characteristics include density, thermal properties, crystalline structure, hardness, tensile strength, machinability, formability, solubility. Application. Polymers can also be categorized by the application in which they are used. Due to the variety of material that can be created through polymerization, polymers are useful in a wide range of applications. Form and molded products, thin films and sheets, elastomers, adhesives, coating paint and ink, yarn, and other fibers. What are plastic? Plastic are synthetic or semi-organic polymers made from oil or petroleum through the use of chemicals and condensation to induce molecular bonding. Although polymers can occur naturally, plastics are entirely man-made. Plastic can be divided into two categories: thermoset plastic and thermoplastic. Thermoset plastic. Thermosets plastic are hardened into a permanent design. Once they have been shaped, thermosets remain in a fixed form even when exposed to heat again. Once set, thermosets will burn rather than melt when exposed to extreme temperatures. Their high resistance to heat and corrosion make thermoset plastic particularly useful in applications that require reliable precision components that will not change shape or grip when exposed to extreme temperature change. Commonly used thermoset plastic include polyurethane, epoxy, phenolic, certain polyester, phenolic.
Due to their durable and temperature-resistant nature, their most are used in variety of applications such as electronic component and insulator, heat shield, motor part and covers, household appliances, lighting components, energy equipment. Thermoplastic. Unlike thermoses, thermoplastic may be reheated and reshaped without any change to their fundamental molecular makeup. They are typically used for plastic products that are not exposed to extreme heat, such as plastic toys, toothbrush, plastic storage container, beverage bottle, and other consumer products. Amorphous and semi-crystalline. Amorphous thermoplastic. Amorphous thermoplastic consists of polymer chains that are not laid out in particular arrangement. The polymer strands are jumbled together in an uneven and disorganized fashion. Amorphous thermoplastic have very low heat resistance but are tough at low temperature. They tend to be clear due to their lack of structure, which make them useful for plastic windows and lighting fixtures. Semi-crystalline thermoplastic. Semi-crystalline thermoplastic consists of polymer strand in an ordered arrangement or a crystalline structure makes with amorphous areas. The amount of crystalline versus amorphous structure determines the physical characteristic of the plastic. The greater the crystalline organization, the opaquer the material becomes. Semi-crystalline, the thermoplastic exhibit greater strength, stability, heat resistance, and chemical resistance than therefore amorphous counterparts. Thermoplastic encompasses a wide range of materials including polyethylene, polyester, polypropylene, polychloride, polyester, nylon, thermoplastic, olefins, xanthophene, arlonitrile, butadiene stray, as adjectives. Their versatility, thermoplastic are useful in myriad industries and applications including blow molding and injection molding, consumer goods, automotive components, engineering and mechanical parts, medical equipment, storage containers, packaging materials.
Thanks for watching.